All right. Velocity of the particle is given by v of t equals all that junk. It gives us a initial position at x equals 2 at t equals 4. So we want to know, first off, is the particle speeding up or slowing down at t equals 4? How do we determine that? Okay, first off, velocity at 4. What's the velocity at 4? We went what? Somebody else had the answer to this because you all did this. What is the velocity?
2.979.
979? People agree with that? Good enough for me. All right. What about the acceleration? Since this is a calculator problem, you just say a of 4, which is v prime of 4, which your calculator would tell you is 16140. 161, good enough. Yeah. And we would then say that at t equals 4, the particle, handwriting is hard. The particle is slowing down. Your reason would be because acceleration at 4 and velocity at 4 have different signs. Easy enough? Everyone go with that? Wonderful. Okay. Part B. Anybody at home have a question on part A? Everyone's good with part A at home?
Do we have to find v of 4 and then v derivative of 4? We can't just find v derivative of 4 and say it's slowing down because it's negative?
No, because if the acceleration is negative and the velocity is negative, technically the speed is still increasing, right? Because if you have, remember that speed is the absolute value of velocity. So if velocity is negative, let's say the velocity is negative 10, let's say v equals negative 10, let's say, and the acceleration is also negative, then that means that it's going from like negative 10 to negative 11 to negative 12 to negative 13 on the velocity. But when you take the absolute value of that, it's 10 to 11 to 12 to 13. The speed is actually increasing. Does that make sense?
Yeah, gotcha. Thank you.
Yep. Question, Emily? You could technically take the derivative of the absolute value of the velocity function on your calculator and see if that's positive or negative. That would also work. Yes. Correct. But you'd have to make sure you put the absolute value in. Everybody good? Don? Question? Oh, you just playing with your hair. Perfect. Okay. Absolute value on your calculator is math, and then you have to go over 2 columns, I believe. 1 column over, and then it's the first option. Got it? Yeah. Cool. All right, part B. Oh, cool, the pen doesn't write now. That's great. Oh, now it writes. Perfect. Find all times t in the interval 0 to 3 when the particle changes direction. So particle changes direction if velocity changes signs. Velocity is only going to change signs for us if it goes through 0. So we're going to see when does velocity equal 0. So whatever our velocity function, we'll graph it on our graphing calculator and see where it has x-intercepts. And that must have happened at what?
2.707.
Is that the only place?
On 0 to 3, yes.
Wonderful. And you would say, this is the only place. Does it go from positive to negative or negative to positive?
Positive to negative?
Wonderful. That'd be part of your explanation. You don't have to indicate positive to negative. You just need to indicate that it changes signs. But everybody go with part B? Right. Part C, find the position of the particle at t equals 0. So to find the position at t equals 0, we need to take its initial position that was given to us and then integrate from whatever time period we had that initial position at to 0 of the velocity. And our initial position was that at x equals, or that x is 2 when t is 4. So we know that we want 2 plus the integral from 4 to 0 of v of t. And then you just plug that into your calculator and get negative 3 point what? 815? Does that sound good to everybody? Everyone good there? Yeah. That is correct. The lower limit will always be your given t value at which you're starting, or where you know the location, and your upper limit is always what you're trying to find. And then the constant out in front that you add is always your initial, or whatever the position was at the t value that you were given. Yep. Everybody good there? Okay. All right, part D. Total distance the particle travels from 0 to 3. Total distance, once again, this one should be pretty straightforward now. Total distance is the integral of the absolute value of velocity, integral of speed. And what that come out to be?
5.01.
Any questions or issues with that one? Y'all good at home with that?
Yes.
Wonderful. All right. We'd already done this one, right, about jogging on the path. So then the next one I asked was about the trains. Yes? And you all did the train problem? We're good to talk about the train problem? All right. Wonderful. We got train A. It's going back and forth on a east-west section of track. And we have a chart, right, that represents the velocities. First off, find the average acceleration of the train between 2 and 8. So how are we going to figure that out? That should just be the slope between, 2 and 8 of the velocity. So negative 120 minus 100 over 8 minus 2. That's negative 220 over 6, so negative 110 over 3. What is that? Meters per minute per minute? It doesn't ask for units, so you don't need to put it, but meters per minute squared if you want. Good? All right. Part A was pretty easy. Part B. We want to know if the data in the table supports the conclusion that the train's velocity is negative 100 between 5 and 8 at any point. Yes or no? Yes? I have a thumbs up from Tom. Yes?
I also said yes.
Yes. Why yes? By what theorem?
The IVT.
By the intermediate value theorem. First off, we know that V sub A is differentiable, which tells us that it is continuous, right? And so that's an initial condition for the intermediate value theorem, that the function is continuous. So since it's continuous and it goes from 40 to negative 120, it must have hit negative 100 somewhere in between there, because negative 100 is between 40 and negative 120. Good? You want to say yes by IVT, you'd say that negative 100 is less than 40, greater than negative 120, and that V sub A is continuous. And you want to give a reason why it's continuous. It's continuous because it's different. Good? Any questions on B? All right, part C. My favorite part of this problem. At time t equals 2, train A's position is 300 meters east of origin station. Very exciting. What a great name for the train station. Origin station. All right. It's moving to the east. We want to write an expression with an integral that gives the position of the train at t equals 12. So we know that at t equals 2, it's 300 east. So its position at 12 ought to be that position, our initial position, plus the integral from that initial time to the final time that we're interested in of our velocity function, as v sub capital A. Right? So there is your integral to represent that position. And then the second part of that is use a trapezoidal sum with 3 subintervals to approximate the position. So do we have equal subintervals? 2 to 5, that's 3. 5 to 8, that's also 3. 8 to 12, that's not 3. So since they're not all the same, we have to break it up and do each trapezoid separately, right? So first off, we're going to have 300 plus, what do we got here? 100 plus 40 divided by 2. And that first interval was 3 units. Second interval was also 3 units, right? 5 to 8. And then we have 40 minus 120. And then the last interval was 4 units. And that one's negative 120 minus 150. Everybody good there? Let me do some arithmetic and get an answer. What did you get for your answer? You did it wrong.
Negative 150.
What did you get? What did you say?
Negative 150.
Negative 150. Anybody else agree with that? Did anybody else do the problem? Didn't do this right. Okay, all right, let's see. What do we got? We got 300, that's 140 over 2 is 70, plus that's 510. What is that? That's negative. Yeah, negative 150. Is that you said? That's what I got. I agree. Negative 150? Still nobody agrees? That's what I got when I did the arithmetic. I'll agree with you.
Yeah, negative 150.
Oh, what happened to my zero there? What happened there? All right. Good? Okay. And the last part is a second train is traveling north from origin station. Oh, we should, just for fun, we could write negative 150, or we could say 150 meters west. Yeah. Of origin station. It was traveling east at that time, but then it started traveling back west because the velocity became negative. So at 2, when it had a positive velocity, it was traveling east, so a negative velocity would be traveling back to the west. No, it's saying at t equals 2, it is moving east. It's not saying that on that entire interval. Everybody good there? All right, part D, our second train traveling north from origin station has this velocity, negative 5t squared plus 60t plus 25. And at t equals 2, it's 400 meters north. We want to find the rate in meters per minute at which the distance between them is changing at t equals 2. So let's draw a little picture. Here's our picture. Here's origin station. Oh boy. And let's see here. Train A is going this way. It started 300 meters. And this one at t equals 2 is, what was it, 200 meters? 400 meters? 700 meters? 1,000 meters?
400.
400 meters. Great. Well, if we want the change in the distance between them, right, that ought to be C. We'll call this A, and we'll call this B, those distances, right? And we want to know how that's changing, so we could say A squared plus B squared equals C squared. And then we could say 2A dA dt plus 2B dB dt equals 2C, that's not a C, dC dt. Yeah? and we're interested in dc dt. dA dt is just the velocity of train A at t equals 2. So what's the velocity of train A at t equals 2? Should be 100. And the
100.
value of A was 300, so this ought to be 600 times 100. Value of B was 400, so that'll be 2 times 400 is 800. And then the value of dB dt at 2, well, what is this? D sub B of 2 ought to be what? 125, you guys agree with that? Yeah, 125? I hope that's right. I didn't do the arithmetic. What was C? They didn't tell us what C was, but if this is 300 and this is 400, that's just a 3, 4, 5 right triangle. So C equals 500 at T equals 2. So this is equals 1,000 times the thing that we are looking for. And what did dC dt come out to be?
I got 160 meters per minute.
160?
Yes.
People agree with that? Yeah? One agreement? Jake, you're good with that? Okay. So much like your brother. It's weird. All right, everyone's good? The dA dt is 100 because we're talking about at t equals 2, and that is the velocity of train A at 2. And then this one, v sub b of 2 was 125, the velocity of train B. Good? Everybody good? All right. And we also did this one, right? Yeah, this was the next one. No, we didn't do this one? This one? Yeah. Oh, fine. Okay. Oh, we got lots of time. This is good. Like we didn't waste any time at the beginning of class. All right. First off, when is the particle moving to the left? Particle is moving to the left if the velocity is negative. So let's first figure out when the velocity is 0, and then we can figure out when it's positive and when it's negative based on that. So when does cosine of pi t over 6 equal 0? Well, whenever the angle equals what? What values, what angles, when you take their cosine, give you 0? Pi over 2, right? 3 pi over 2, and so on, 5 pi over 2, 7 pi over 2, 9 pi over 2, 11 pi over 2, 13 pi over 2, 15 pi over 2. I know my odd numbers. Look at me go. Okay. So then we just solve each one of these. Pi t over 6 equals pi over 2. So this one gives us t equals what?
3.
3. This one gives us t equals, cancel out the pi's. What do you
9.
get? 9, right? Next one, 5 pi over 2. What would 5 pi over 2 give us?
15.
15. 15 is not on our interval. So we can just look at 3 and 9, right? And we want to make sure that as we make a chart to check these, we don't check values outside of 0 and 12. Everybody good? Okay. Then we plug in a value, something between 0 and 3, like, I don't know, 1. That gives you the cosine of pi over 6. What's the cosine of pi over 6? Is it positive or is it a negative?
Positive.
Positive. So we're moving to the right. Plug in something between 3 and 9, like let's say 6. 6 is an easy number to plug in there, right? Gives you cosine of pi. Cosine of pi is -1, so negative. So we're moving to the left. And then what about between 9 and 12? Plug in 10, you got cosine of 5 pi over 6. I mean, sorry, 10 pi over 6 is 5 pi over 3. And that's cosine in the fourth quadrant, right? 5 pi over 3 is in the fourth quadrant. Cosine in the fourth quadrant is
Positive.
positive. Yeah. You remember, because all students take calculus. Remember that? Did you learn that? Nobody taught you that? Nobody taught you that? That's the only abbreviation you should ever know. Did you really never learn that? Nobody ever. Hold on one second. Okay, how y'all doing? Everybody doing good? You guys good in the Zoom there?
Yes.
Oh, wonderful. Okay, so this, all students take calculus. It's like your NGL and your PLS and your no, it's not like the PLS. It's like the NGL and it's like the TY and the TBH, all of that little weird crap you guys do, right? This is all students take calculus. It tells you which functions, which trig functions are positive in which quadrants. They're all positive in the first quadrant. Sine, S, is positive in the second quadrant, as well as its reciprocal, right? Cosecant. All the other trig functions are negative in the second quadrant. Tangent is positive in the third quadrant, as well as its reciprocal, cotangent, right? But all the other ones are negative. Cosine is positive in the fourth quadrant, along with its reciprocal, secant, but all the other ones are negative. All students take calculus. All students take calculus. Great. I've also sometimes said, when I used to teach honors pre-cal, I always said, all C students take stats. But I don't know. That was unkind, probably. Probably shouldn't have said that. But I agree. All right, so anyway, we know that in the fourth quadrant, cosine is positive because all students take calculus. Even those that shouldn't sometimes. They all do it. All right, so anyway, so we've got from 3 to 9, it's moving to the left, right? Left from 3 to 9. Easy enough. Not me putting that on the AP exam skull. What? I don't know what it means. Not me putting that on the AP exam. And then a skull. So he's dead from laughter because he didn't put this on the AP test? Because he will be putting it on the AP test. Okay, wait. But he mentioned it. Wait. Say that again. I'm going to understand this.
I am going to sarcastically state that I will not acknowledge.
You as Josh.
Yes.
You as Josh. Tom as Josh is sarcastically stating.
I am sarcastically stating that I am not acknowledging this, and due to my lack of acknowledgement, I am upset from that. So, like, I am not going to acknowledge the fact
Okay. All right, I'm gonna see if I got this, so that I can build my social media TikTok empire. Apparently, because apparently that's what children need from me. Apparently, is me to build my TikTok social media empire. Josh is going to put all students take calculus on the AP test. Okay. Now, okay, I'm not finished, Josh. Stop commenting while I'm trying to talk. He is going to put all students take calculus on the AP test. Now, that is embarrassing. So he's going to say, not me. So like he's, okay, let me start over. All right, Josh is gonna put this on the AP test. He's gonna write all students take calculus on the AP test, which is an embarrassing thing to do, but he's going to mention it because it's funny to everybody else that he's gonna mention it, but he's saying not me to pretend like he doesn't really want to say that he's doing it, but then he's putting the skull emoji to indicate that he is laughing at the fact that he's embarrassed by the fact that he's going to type this on, or write this on the AP test. Is that correct? Did I get it? Sonakshi, are you okay? Say something. Is she really? That's sarcasm. Sonakshi, say something. Type something. Oh, good. Whew. Okay. Okay. Whew. Josh, are you still with us?
Yes, I am still here.
Josh is still here. Okay. Okay. Melanie is going to be my social media manager. She's going to teach me how to use TikTok. I don't, or she doesn't? Okay, all right, let's continue. Oh, I was recording all that. Perfect. Okay. Good. Yeah, that's good. That'll be that. So that's something I can put on the social media. Is I can clip me trying to explain what my student. Perfect. Yeah, that's what I want, is people to laugh at my expense as an old person.
But you turned your camera off.
Right.
It'll go more viral if your camera's on so they can see your facial expressions.
My social media manager sucks, apparently. I don't know. She's not very good at this. Anyway, part B. We got to get through this problem here. Yeah, we've already done other problems. Relax. All right. What? Yes, I am, Philip. Go away. All right. Part B. Right, but do not evaluate an integral expression that gives the total distance traveled by the particle from t equals 0 to t equals 6. So, total distance is an integral of absolute value of velocity, or integral of speed. So part B, I have room here. We'll just do this. The integral of absolute value of velocity. We have to, it's not a calculator problem. We have to actually do this. Oh, perfect. Great. Done. Don't evaluate. Done. Easy. You guys read better than I do. Good. Stop calling me old, Tom. Where'd that page go? I had a page in there. Technology. Part C. Are we ready? Find the acceleration. How do we find the acceleration? Take the derivative. So A prime equals the derivative of cosine pi t over 6. That derivative is chain rule, so that should be negative sine pi t over 6 times the derivative of pi t over 6, which is pi over 6. And we want to find it at 4, is that right? So that should be the negative sine of 2 pi over 3 times pi over 6. Sine of 2 pi over 3, that's in the second quadrant, so it will be positive because all students take calculus. And then what? What is the sine of 2 pi over 3? You gotta tell me what it is. Square root 3 over 2, pi over 6. Simplify to negative, I mean, it doesn't really simplify, negative pi root 3 over 12. So the acceleration is negative. Then we need to find out to determine if the speed is increasing what the velocity at 4 was. Did we already do that? No. The velocity at 4 is just the cosine of 2 pi over 3. Cosine of 2 pi over 3. That's in the second quadrant where cosine is negative. So we know it's negative. And what is it? It's negative half. Right. So this is less than 0. This is less than 0. The speed. This is what it asked, right? Was the speed increasing or decreasing? Okay. The speed is increasing because both of them are negative. Everybody good with part C? Good. Any people at home have questions on part C? Okay, part D. Find the position of the particle at t equals 4. So position of the particle is the initial position plus the displacement. Our initial position is -2. So -2 plus the integral from 0 to, what did I say, 4? Cosine pi t over 6 dt. Everybody good with the setup? And then how do we integrate this? This is cosine of a function. So we have to do a u sub. U is pi t over 6. And du will be pi over 6 dt. What do we do with the pi over 6? We got to throw it in here, right? We got to put a 6 over pi outside. And we'll end up with -2 plus 6 over pi times the integral of cosine u du. From 0 to 4? No, not from 0 to 4. From
0
0
to over 3.
to pi, is it? Yeah, to 2 pi over 3, right? Plug in your x value, so your t value of 0 to get u is 0. Plug in your t value of 4 to get 2 pi over 3. And now we have -2 plus 6 over pi times the sine of u from 0 to 2 pi over 3. We got -2 plus 6 over pi. Sine of 2 pi over 3 is still
Root 3
root
over 2.
3 over 2. Sine of 0 is 0. Simplify to -2 plus 3 root 3 over pi. Good? Any questions on that one? Any of the parts of that one? Yeah. Uh-huh. Yep. You still set it the same way. Normally what we do, like if it was 4 to 0, you can do it that way. Then you just end up with 0 minus the root 3 over 2 if it had been that way. Or you can just flip it to make it 0 to 4 and put a negative out in front. Either way, it's fine. Usually for the, remember we did a couple of those, like, we did like 1 or 2 of the ones that were all graphs for the FRQs. Those ones, it's really, you really want to flip them so the lower limit is smaller than the upper limit. Otherwise, it kind of screws you up. But for like a regular integral like this, it's not so bad. Just make sure you evaluate in the right direction. Any other questions on that one? Everybody good there? Okay. All right, now we've got Ben and his unicycle. Exciting. And you guys already did this one too, right? Yeah. Good. So first off, we want to use the data in the table to approximate his acceleration at t equals 5, right? So how do we approximate the acceleration? That's just a slope of the velocity on the interval surrounding 5. So we'll say part A ought to be 2.3 minus 2 over 10 minus 0, or 0.03. Indicate units of measure. what is it? Acceleration, meters per second squared. Make sure you put the units. And on the scoring guide for this one, it says that if you had the right units in either A or B, they gave you 1 point. So it says using correct units in both of them. There was 1 point associated for the right units in one or the other of them. You only, if it says indicate units, you have to put it. If they do not say indicate units, they are not going to, there will not be points associated with it. So, yeah. All right, part B. Interpret the meaning of the integral from 0 to 60 of the absolute value of v. So that's the integral of speed. Integral of speed is, no, integral of speed is total distance traveled. Make sure you are careful with your wording, right? The integral of velocity is position or displacement. The integral of speed is the total distance traveled, regardless of the sign of the velocity. Total distance traveled from t equals 0 to t equals 60 seconds. So all he wrote his unicycle for was 60 seconds. Not very impressive. I could most certainly ride a unicycle for more than 60 seconds. There's no doubt about it. I don't own a unicycle. If somebody brings me a unicycle, then I could ride it for more than 60 seconds. In fact, I could probably ride it at a velocity greater than 4.6 meters per second. Actually, never mind. I don't know if I could do that. I mean, it's not that fast. Why would I have to go over 100 meters? Well, I haven't done the problem, so maybe if I've done the problem. Let's find out. All right, let's use the left Riemann sum to indicate or to evaluate this integral, right? So we're talking absolute value, so we change all of these to positive. Well, they're already positive, so that's easy enough. So for the rest of part B, using a left Riemann sum, our first interval is 10 units, and our height is 2. Our second interval is 30 units, and our height is 2.3. And our last interval is 20 units, and it's 2.5. And what do we get here? 139 meters. Okay, so yeah. Chances are I'd have to go more than 100 meters in that minute. That is true. I think I can do that. It seems easy. It's got a pedal, right? Unicycles have pedals, yeah? They must. How else would you get? Yeah, balance is easy. You just don't fall over. All right. Is this, everybody good with that? Everyone okay with part B? Part C. This is a good one. I like this one. For part C, is there a time where the velocity is 2 meters per second? So there's two different things we have to check for this. One would be like a couple problems ago, we used the intermediate value theorem. Right? So we would look at the velocity and see if the velocity goes below to above or vice versa 2 on that interval. Does it? No. So not by the IVT. But we also have to check with something whose derivative, if we have that function available, whose derivative is the velocity. So the function whose derivative is the velocity is the position equation, b of t. So we will look at the average rate of change of b. We'll look at b of 60 minus b of 40 over 60 minus 40 and discover that that is 2. 49 minus 9 is 40. Over 20 is 2. So the average rate of change that he had between 40 and 60 was 2. So by the mean value theorem, v of something equals 2 on 40 to 60. Right? Because the function is differentiable, which means that it's continuous and it's differentiable. And the average rate of change of the position was 2. So the instantaneous rate of change of the position velocity must have been 2 sometime. Good? Any questions on C? What?
So if they give you, if like, for example, for this one, they gave you both like the B of t and the V of t. So if they do give us both, should we need to check both?
Well, if one of them, I mean, if you check the mean value theorem first, then you're good. You don't need to bother with the intermediate value
Okay.
theorem. Or vice versa. If the intermediate value theorem works, then don't worry about the mean value theorem. So,
Okay.
yep. All right, everybody good there with C? Everyone's good with C? You get nothing for checking with the IVT. Yeah. I believe I didn't pull them up for this one. I haven't pulled up the Theorem, I guess. I think it was 2 points. One for finding that this average rate of change was 2, and then 1 point for making the conclusion that it must be because of the mean value theorem. Yeah, but the IVT gives you nothing for that because. All right, part D. We are now talking about a light on the track, and that the distance between Ben and his light is L squared equals 144 plus B squared. So we're going to say L squared equals 144 plus B squared. And we want to find the rate at which the distance between him and the light is changing, right, where L is the distance between him and the light. So this is a related rate. We're going to take a derivative with respect to t of everything in here. So 2L dl dt equals 0 plus 2b db dt. Yeah, everybody good there? And we're talking about at what time? T equals 40. So at t equals 40, his position is 9, right? So that's what our b value is there. And what is our db dt value at t equals 40?
2.5.
Should be our velocity. It should be 2.5. dl dt is what we're looking for. 2 is just 2. What is L at that time?
15.
Exactly. L squared must be 144 plus the b value squared. So that was 9 squared. So this is 144 plus 81, which is 225. So L must be 15. So you got to go back to that initial equation they gave you, plug in the b value to find that 15. And so this ends up being dl dt equals, I don't know, what is that, 18? Well, we're going to get rid of the 2's, 9, 15, so 3, 7 is that 7.5 over 5, so 3 halves. Yeah, that's what you guys got, 3 halves. Yes, no, maybe. Yeah,
Yes.
you did the problem wrong. So you didn't get 3 halves. The 3 halves was doing it right. That one, I believe, was 3 points. 1 point for correctly taking the derivative, doing implicit differentiation with respect to t. They gave you 1 point for recognizing that dB dt was the velocity at 2, so plugging in 2.5. And then they gave you 1 point for the final. Any other questions on that one? Are you all ready for your motion pre-response question quiz tomorrow? 1 calculator, 1 non-calculator question. You'll have 30 minutes. I might be nice and give you a couple extra. At least 30 minutes. Any questions? Everybody's good? All right. If you want to work on any more of them between now and tomorrow, go for it. There's plenty in there. Just send me questions if you have them. I'd be happy to answer them. And I guess Zoom people, you're good to go if you are wanting to. The rest of you got a couple minutes.